Okay, so on your left hand side, this is an example of convex sets. Okay, so no matter, you can randomly pick 2 points within this set. That set is x and y, and you draw a line between them, a straight line between them, and figure out what is the linear combination between these two points. Okay, and you will figure it out the whole line falls within this set. Then this is a convex set. On the other hand, here, although I can still find some point that satisfy these conditions, there exists a pair which is like this one. I'll call it x1 and y1. And when you do the linear combination, you will figure out oh, okay, so I got some trouble here. This point is not within the set D, so this is not a convex set. Okay. And similarly, we will have convex functions. And how does that look like? Okay, so this is how the convex function is defined. So this is the convex functions. We randomly, arbitrarily pick 2 points in the domain x, y. Okay, and we find that any linear combination between these 2 points in the domain, which is this interval. Okay. And we compare the image of it. So we also do the linear combinations between the image of f of x and f of y. Okay, and we found that the linear combination of these two, of the image of these 2 points, is always greater or at least equal to the image of the linear combination of these two, of linear combination of the original 2 points that you pick. Okay, so you will see a graph look like this one. Okay. And of course, that we can also have the concave functions here. Okay. Although I don't think we have the concave set. No, right. We have convex set. We have convex functions and concave function, but we do not define something like concave set. Okay, so just pay attention to it. Now I'm going to draw another expressions for the concave functions. Okay, so we kind of like flip the relation here. Now it's like we pick up any 2 points in the domain, and we found that the linear combinations of f of x and f of y is always smaller or at least equals the wing. Yeah, so it's always smaller or at least equals the f of the linear combinations of these 2 points. Okay, so that is the definitions. And on top of it, we also have quasi. I kind of hate quasi, the word quasi here. I mean, a lot of quasi stuff. Quasi-convex functions and quasi-concave functions. Okay, so just give you an example. I'm going to put down another graphic here. Right.